So there are a few things that change when you're talking about tangent and cotangent compared to what we're used to with sine and cosine. And one of those things is how you calculate the period of the function. If you remember from the unit circle, I've got a unit circle down here somewhere. There we are. We've got this unit circle here, and the period talks about how long it takes for the function to repeat itself. Well, with the sine and cosine, if you remember, you have to go all the way around the circle before it repeats itself. But with a tangent function, you only go halfway around the circle. Okay, it repeats more rapidly. So you can see why the formula for calculating period is going to be a little bit different. And what we do, we still look at b right here. I'm going to pick on this one because that's got a nice obvious b that I can use. You still use b, but the new formula is this. You say p equals pi over b. And that should set off some alarm bells because we're used to it being 2 pi over b. Well, for tangent, cotangents, it's pi over b. So let's go through this example with 3/7 and see what that would be. Okay, period equals pi divided by 3/7, which I prefer to think about my division this way. Pi over 1 divided by the fraction 3/7. And if I write it in the old-fashioned 4th grade style, then I can easily flip my fraction around and turn it into a multiplication problem. Remember, keep, flip, change. So this becomes a period of 7 pi over 3. And you'll get very fast at this as you get some practice. You see, most of this equation that I have here is just distraction. If all I care about is the period, then all I need is the b term right here. I don't need the vertical scaling factor. I certainly don't need midline, right? I don't need phase shift. These are all irrelevant. So let's do another example. How about this guy up here? This looks weird. What's weird about this one? You should notice that b is not clearly defined. I don't have it separated out like I did in the middle example here. So what you have to do is you have to go to the work of factoring this out. Let's do that example. -3 tangent, that part doesn't matter. It's going to be something factored out like this. You have your -2, that also doesn't matter. So what's factored out? Well, what is multiplied by x? Right? If I were to factor out some number so that only x is left on the inside, what does that number have to be to get 3/8 x? Well, it's 3/8. Okay, so that's what b is. b equals 3/8, which means p, the period, equals pi divided by 3/8. And using the same keep, flip, change trick as above, I won't go into as much detail, but it's going to be 8 pi over 3. Okay, so that would be my value for the first answer up there. Now, one more example. Let me switch color. This is getting a little confusing. How do we do this one? Right here. That's b, 8 pi over 3. And some people get confused when they see a pi there. But don't worry about it. It has no effect. That's important. The number is going to look a little different as a result, but all you do is you take pi divided by b. Okay, so divided by 8 pi over 3. And let's go through that keep, flip, change trick one more time. This is going to be pi over 1 times 3 over 8 pi. Okay, so what happens? Well, the pi's cross out. That's kind of nice. And all I get is 3/8 left. And it may look a little weird to have a period with no pi on it. That just means that when you try to graph this function, you're going to have tick marks on the x-axis that don't have pi's in them. They'll be like 1/2 and 1/4 and 3/8 and those sorts of things. But the only reason that's happening is because there was a pi in this function right here. It's no different mathematically. It's just a different way of presenting the number, and it produces different tick marks on the graph. But you don't have to do anything differently in terms of how you calculate a period.